Hi everyone, in this video we will go through what are these linear equations and how to solve them simultaneously with elimination method. Any equation that can be modeled as ax plus by equal to c form, that can be called as a linear equation, specifically with two variables. So let's take a concrete example, right? Let's take an equation called 2x plus 3y equal to 13. In this case, 2 and 3 are essentially coefficients and x and y are the variables. And for this particular video, we are sticking with the linear equations with two variables. Just to simplify it, you can stretch the conversation and the concepts that you learn for two variables to n number of variables. But importantly, the degree of this particular equation needs to be 1 to be qualified as a linear equation. Also, another property which is important for these linear equations, because they are equations at the end of the day, is that you can apply the multiplication property of equality and division property of equality to these equations as well. So for example, if I have to multiply the left side with say 5, I need to multiply the right side with 5 so that I can keep respecting this equality between the left hand side and the right hand side. Therefore, this equation would turn into 10x plus 15y equal to 65. So what essentially I've done it is I've multiplied 5 by 2, 5 by 2x and 5 by 3y, and then I get this new term called 10x plus 15y equal to 65. So let's apply elimination method to solve simultaneous equations. Let's take an example. So I have the first linear equation called 2x plus 3y, which is equal to 13. And I have another linear equation called 5x plus 2y, which is equal to 16. Now, what elimination method says is that you need to eliminate one variable out of the two, and then it becomes one equation of one unknown, and then it's easy to find the value of a particular variable that has been left out. So in this, and we have a choice to eliminate either x or y. So in this particular example, I'll show you how to go about removing variable y, but the same process applies to if you choose to remove a variable x as well to start with. So let's say that if I multiply the first equation by a number which is 2, and if I multiply the second equation by a number 3, then the transformed equations would become 4x plus 6y, which is equal to 26. See, what have I done? 2x multiplied by 2, 3y multiplied by 2, and 13 multiplied by 2. So nothing fancy here. 2x multiplied by 2 gives me 4x, 3y multiplied by 2 gives me 6y, and 13 multiplied by 2 gives me 26. And the same thing I'll apply here as well, that I have 5x multiplied by 3 will give me 15x. I'll have 2y multiplied by 3, which will give me 6y, and I'll have 16 multiplied by 3, which will give me 48. So far so good. Now one thing that I need to clarify, why did I multiply the first equation by 2 and why did I multiply the second equation by 3? Well, see, the coefficient of y in the first equation is 3 and the coefficient of y in the second equation is 2. So if 3y and 2y, if I want to get them to the same value, then I need 6y in both the cases. So therefore, I multiplied the first equation, which has got the coefficient of 3, by 2. So I have 3 times 2, which will give me 6y. And for the second equation, I have 2y and I need 6y. So I have to multiply that by 3. So I chose multiplication factor of 3 in the second equation. But well, whenever I apply a multiplication on the left side, I have to apply that on the right side as well. And that's what we have transformed it, these first two equations into this next two equations, which are 6x, 4x plus 6y equal to 26 and 15x plus 6y equal to 48. So essentially they are the same equations, it's just that the coefficients are now more favorable for us. Now you look at 6y and 6y. Now how do we get of 6y and 6y? It's an easy process now. It's just a matter of subtracting the second equation from the first equation, and then we get 6y minus 6y, which is essentially removing the variable y, 0y, which is essentially y. So let's start from the left side. So 4x minus 15x, which will give me minus 9 minus correction 4x minus 15x, which will give me minus 11x. 6y minus 6y, so 6y will get cancelled out, and 26 minus 48, which will be minus 22. Now I divide both the sides by minus 11. Again, the division property of equality. And what do I get on the left side is x, and what do I get on the right side is 2, because minus 11 times 2 is minus 22. So this is where I get my first value, which is x. Now I have a choice of plugging in the x value to either of these equations, the first equation or the second equation, to get the value of y. So let's choose the first equation, 2x plus 3y equal to 13. Therefore 2 times the value of x that I have gotten plus 3y will give me the value of 13. So far I have just plugged in the value, nothing fancy so far. 2 times 2 is 4 plus 3y, which is equal to 13. What do I need to do now? Just subtract 4 on both the sides. Then I get 4 minus 4, which is 0. Then I get 3y equal to 9. Divide both the sides by 3. What do I get? Y equal to 3. 3 times 3 is 9. So I get my second value here. Now let's make sure that by plugging in the value of this x and y, both the equations are satisfied, right? So let's stick to finding out on both the equations here. 2x plus 3y, which is equal to 13. So let's make sure if the left hand side and right hand side match. Let's substitute the value of x, which is 2, value of y, which is 3. Again, question mark, because we don't know whether the left hand side is going to be equal to right hand side or not. It's 2 times 2 is 4, 3 times 3 is 9, 13. Yes, it does make the left hand side equal to right hand side. Let's apply the same process for the second equation, which is 5x plus 2y is 16. 5x plus 2y equal to 16. And let's make sure that we have the value of x, which is 2, plus value of y, which is 3, whether it satisfies the value and make the left hand side equal to right hand side or not. So 5 times 2 becomes 10, 3 times 2 becomes 6, that makes it equal to 16. So the left hand side again is equal to the right hand side. Therefore our solution for this simultaneous equation is 2, 3, and 2 is the value of x and 3 is the value of y. Let's take a look at few other examples. So let's say this time we have these two linear equations, 2x plus 3y is equal to 13 and five x minus 2y is equal to 4. Now again we have coefficient 3 and coefficient 2 here, so least common multiple of 3 and 2 is 6. So let's transform this equation. Let's multiply the first equation by 2 and the second equation by 3. So we get 4x plus 6y equal to 26 and 15x minus 6y is equal to 12. Same process, multiply by 2 on both the sides in the first equation and multiply on both the sides by 3 in the second equation. The specific thing that I would like to bring it up here is that, remember last time around when we were looking at these transformed equations, we had to subtract the second equation from the first. And the reason for that was that the first equation had 6y and the second equation also had 6y. So to eliminate the variable y, we needed to subtract 6y from 6y, and therefore we chose to go with minus for the second equation. But we don't have to restrict ourselves to minus only. In this particular example, we have plus 6y and minus 6y directly available, and in this particular case, therefore, if we add the first and the second equation, then plus 6y and minus 6y, when they are added up together, they will naturally get eliminated. So in this particular case, if we just add both the equations, then we get 19x, 6y and minus 6y get cancelled out, and we get 38 here. And then the value of x, if we divide both the sides by 19, then we get x equal to 2. So this will be our answer, and plug the value of x back into one of these equations and we can find the value of y. Let's take another example. Let's say we have x plus y is equal to 4, and we have another linear equation called x minus y equal to 2. Now in this particular case, there is no essential need of any manipulation of the equations. The reason is that plus y and minus y, if we just add these two equations together, then one of the variables will be eliminated automatically. So if we do addition of these two equations, then we get x plus x is equal to 2x, y minus y, y plus minus y, which is y minus y, which will get eliminated, and 4 plus 2 will become 6, and therefore x will become equal to 3. And then again plug the value of x back into one of these equations and you can find the value of y. So by bringing in these two different examples, I just want to communicate the fact that not all the time you need to manipulate the equations. If the coefficients are very favorable to start with, you don't need to manipulate the equations. Not all the time you have to subtract the equations. If the values have been such that they are directly, if two equations get added up, then if they nullify directly, then you don't need to subtract the equations as well. And in this particular, in the first example which we saw it, we had to subtract it because 6y and 6y were both positive values. So putting the subtraction in between, we can get rid of y. Another point to note is that whatever operation we apply on the left side of the equations, we have to apply on the right side. So if we have equation 1 plus equation 2 on the left side, we need to do equation 1 plus 2 on the right side as well. And if we have to do equation 1 minus equation 2 on the left side, we need to do equation 1 minus 2 on the right side as well. So these three examples probably will give you a little bit of a color as to how to go about these problems. This concludes this video. And if you are looking at videos on any specific topics, please communicate to us in the comment section, and thank you for watching. Good luck.